Hello there, and welcome back to The Sleepy Science, the channel where vast cosmic mysteries meet the soft hum of your bedside fan, and your brain gets gently tangled in the weirdest stuff the universe throws our way. Tonight, your eyes are fixed on a patch of sky that seems just a little too quiet. Out there, far beyond the orbit of Mars, past the places your childhood solar system poster used to end, something is moving, slowly, silently. With all the suspicious nonchalance of a cat in a room full of rocking chairs. You can't see it yet, not with your eyes, but it's there, and it's not from here. You probably won't survive this. Not because it's dangerous, no fireballs, no doom cults this time, but because the implications might quietly short-circuit that tiny, hopeful part of your mind that wants the universe to play by some kind of rulebook. You're about to meet an object that doesn't belong in our solar system, doesn't care about our gravity, doesn't stay in our lanes. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, tell me in the comments where you're watching from and what time it is. Midnight in Minnesota? 3:12 AM in Perth? I always read them. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You first catch wind of the visitor in the form of a low-resolution alert from an automated survey telescope. It's a speck, a moving one. Just a dot, really, yet its path through the sky doesn't match any familiar arc. It's too fast. Not fast in the thrilling rocket ship sense, but fast in that long-haul, million-year galactic cruise kind of way. The kind of fast that says, I've been around. The telescope that spotted it is part of a TLAS, the Asteroid Terrestrial Impact Last Alert System, which sounds like the name of a robot security force but is really just a couple of Hawaiian telescopes that spend their nights scanning the heavens for anything headed uncomfortably earthward. Most nights, they catalogue boring things. Space pebbles, satellite streaks, some tired meteoroid with no real story to tell. But tonight something very much not local has tripped the wire. The object gets a temporary name, 2024 QZ1ATLAS, but it won't stay that way for long. Within days, its trajectory is confirmed as hyperbolic. That word means exactly what you hope it doesn't. Not an ellipse, not a circle, not even a wildly stretched oval. A hyperbola means this object isn't coming back. It's not orbiting anything, it's just passing through. You may remember this kind of celestial behaviour from two previous troublemakers, 1I/Oumuamua in 2017 and 2I/Borisov in 2019. This new one? It's 3I/ATLAS, the third interstellar interloper, and even though it looks like just another blurry smudge in the telescope feed, astronomers around the world sit up straight in their swivel chairs and begin to salivate slightly. Why? Because interstellar objects are like the postcards of the universe. They don't arrive often, they're often scuffed and vague, and half the time you're not sure if they're heartfelt or threatening, but they always have stories attached. You're watching the data roll in, and already it's breaking the rules. The object is faint, its albedo, that's the reflectivity, is weird, and it's not behaving quite like anything we've logged before. It has no tail, no visible outgassing, and yet it glints now and then as it spins, like it wants to get your attention but isn't sure how. Out here, in the mental twilight between curiosity and cosmic vertigo, you start to grasp how rare this is. Historians of astronomy still argue whether comets in the Middle Ages ever came from other stars. Were any of those hairy stars in old Chinese records interstellar? The data's long gone, but now, with computers and orbital mechanics and way too much caffeine, we can spot a trespasser like this one and say with some certainty, it's not from our neighbourhood, and that's unsettling. Because interstellar space is not some magical road trip zone. It's dark, cold, and hopelessly vast. Nothing just wanders in unless it's been hurtled, lost, or thrown away. You watch this object's trajectory, how it enters our solar system at a steep angle, cuts across the plane like someone sprinting through traffic, and aims for the exit with total disregard for orbital etiquette. You lie there wondering, where did it come from? Not just physically, though that's a mystery too, but why is it here? What are the odds that 3 interstellar objects have suddenly shown up in our sky in just the last few years? It took until 2017 to find the first one, then 2 more in under a decade. That math starts to feel fishy. Maybe our detection systems got better, or maybe the universe is dropping hints. A fringe theory floats into your half-sleeping brain. What if interstellar objects are not random at all? What if some of them are placed? Sure, that sounds like science fiction, but so did non-spherical asteroids and neutron stars once. Carl Sagan used to say, extraordinary claims require extraordinary evidence. But also, the universe doesn't care about your comfort zone. Some scientists joke that the space between stars is like a cosmic junk drawer. You never know what you'll find rattling around in there. A lost probe, an ancient relic, a planetary shard from a system long dead. Others argue, more soberly, that most objects like this are just icy planetesimals ejected during system formation. But even they admit it's still a guessing game, and this latest one, 3I/ATLAS, doesn't quite fit the expected shape. You stare at the simulation of its path on your screen. It's a single, clean arc through a solar system that has otherwise spent 4.6 billion years keeping its planets in order. This visitor just cuts through like a hot knife in an indifferent cosmos. Eventually you stop trying to categorize it. You stop trying to force it into comet boxes or asteroid drawers. You just lie back and accept that something very old, from very far away, is flying over your head. It doesn't care if you understand it. It doesn't know you're watching. But it's there. And for the first time in a while, the sky doesn't feel like home. It feels like a hallway, with something walking past your door. You're still lying there, half lost in the dark, and the realization starts to settle into your bones. This is not the first time the universe has tossed something strange into our neighborhood. You've met this kind of cosmic trespasser before, or at least its ancestors. 2, to be precise. The first one arrived when everyone was busy arguing about politics and phone batteries, back in the warm, forgettable haze of 2017. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. That name was no accident. It came and went with all the subtlety of a ghost flicking the hallway light switch at 3 a.m. You remember Oumuamua vividly, how it sparked a frenzy. It shot through the solar system on a hyperbolic path, the first object ever confirmed to be from beyond our star. It wasn't round, it wasn't icy. It tumbled end over end like a paper airplane someone threw wrong, and it accelerated. Slightly, but weirdly. With no visible thrust, no tail, no outgassing. Just a stubborn refusal to slow down the way it should have under Newtonian expectations. Scientists offered explanations, of course. Gas release, thermal effects, pressure from sunlight. And yet, none of it ever quite fit right. It was like someone describing a cat as a kind of dog that just has different priorities. Technically plausible, but still wrong. Historians still argue whether Oumuamua was natural or artificial. Or, more sneakily, whether we can ever really tell the difference when the thing refuses to slow down and pose for a family photo. You may recall how Avi Loeb, a Harvard astrophysicist, stirred the pot by suggesting it could be a piece of alien tech, something like a light sail. Naturally, the internet melted. Astronomers rolled their eyes. But Loeb doubled down, published a book, and got people talking. Whether or not he was right doesn't matter. The important part is, something came, and we didn't understand it. Then, barely 2 years later, another stranger showed up. 2I/Borisov, a very different beast. Unlike its elusive older cousin, Borisov behaved more like a comet. It had a tail, a coma, and a volatile-rich surface that made astronomers sigh with relief. Ah, they said, a normal alien thing. But even Borisov had its oddities. It was unusually carbon-rich. It spewed more CO2 than expected, and its structure was fragile, likely to shatter from solar heat before ever completing a proper loop. You watched it fray like an ancient book page caught in a breeze, shedding particles and secrets as it sped back into the dark. Now, with 3I/ATLAS on the scene, you've got a cosmic trio. Like strange siblings, each interstellar object comes bearing family resemblances and troubling differences. Oumuamua was evasive and quiet. Borisov was dramatic but predictable. And now Atlas, the third, glides in with unsettling silence, an unknown wrapped in a riddle scribbled in math. You start comparing them like old friends, trying to guess what kind of company you're keeping. Atlas seems closest to Oumuamua. No tail, no coma, no fireworks. But also no obvious acceleration. Just that same unblinking quiet path through the system. If Oumuamua was a whisper and Borisov a shout, then Atlas is the pause in between. It's tempting to call this a trend. 3 interstellar visitors in 8 years, when we went centuries with none. but your rational brain interjects, maybe we've only just gotten good at noticing them. The past few decades brought better sky surveys, automated detection algorithms and machine learning systems trained to flag unusual motion. You think back to the history books. Comets terrified people in the Middle Ages. They were omens, portents, divine curses. But maybe, just maybe, a few of those ancient sky streakers weren't from here either. No one could have known. One fringe theory, one you can't help but entertain in your half-drowsy state, suggests that Earth has always been visited by interstellar objects. We just didn't recognise them. Some may have entered the atmosphere, flared up, burned out. Maybe one or two even touched down. You picture a meteorite quietly sleeping in some museum drawer, catalogued decades ago, with a chemical signature no one bothered to double-check. It's an alluring idea that the first interstellar object wasn't Oumuamua at all, but some random chunk of rock that fell in Siberia 200 years ago and has been quietly ignored ever since. Historians and planetary scientists don't always get along, but even they agree on one thing. We don't know how much we've missed. The sky is big. The gaps in our records are bigger. For every object we've logged, 1,000 more may have passed unseen. The telescope is only awake part of the night. The software only sees what it's told to find. And then there's the timing. You can't help noticing that these three objects arrived just as our civilization reached a certain threshold of awareness. We're no longer earthbound, not really. Space probes drift far beyond Pluto. Mars gets visitors like it's a weekend Airbnb. We've got telescopes on mountaintops and in orbit, all whispering their data back to Earth every second. You wonder, are we being noticed too? Not in a cinematic UFO abduction kind of way, but in the gentler sense, like ants finally making enough noise for someone across the field to lift their head. Or maybe it's just cosmic randomness. That possibility lulls you slightly. Randomness is safe, boring. You wrap it around you like a blanket, but it doesn't hold for long, because randomness doesn't feel like what's happening. You have 3 known interstellar objects, in quick succession, with traits that don't quite match, and each one has arrived with just enough time for us to see it, barely, as if they wanted to be spotted, but not studied. And so you lie there in the dim glow of your screen, watching Atlas arc across simulated sky charts like a skipping stone, and you wonder, how many more are out there? Are we looking at the beginning of a new era? An age where the solar system is no longer a quiet cul-de-sac but a crossroads? You don't have answers, but you do have questions, and right now that's enough to keep you awake just a little longer. You find yourself staring at the name 3/2024 QZ1 Atlas. It's not poetic like Oumuamua, or even oddly romantic like Borisov. It's bureaucratic, cold, a string of catalogue codes sandwiched around a corporate-sounding acronym, and yet it's in that name, a TLAS, where the story deepens. Because this isn't just a rock with a passport from somewhere beyond Alpha Centauri. It's a discovery brought to you by a very sleepy but vigilant eye in the sky. ATLAS stands for the Asteroid Terrestrial Impact Last Alert System, a pair of sky-scanning telescopes perched in Hawaii, like overworked lifeguards watching for the next rogue wave. Designed to spot potential Earth impactors with enough time to let someone, anyone, do something about it. These telescopes sweep the night sky automatically, comparing frame after frame, looking for movement, for change, for trouble. Every night, thousands of objects are seen. Most are boring, satellites, already known asteroids, sometimes even the odd smudge from a passing bug on the lens cover. But on August 16th, 2024, Atlas spotted something different. A blip, moving too fast, coming in too steep, no match in the catalogue. Atlas flagged it, ran the math, and then, like any responsible stargazing system, it tattled. Within hours, observatories across the world scrambled to confirm it. Observers at Mauna Loa, then in Chile, then in Spain. Each one watched the object's path, fed its motion into orbital models, and got the same answer. This thing wasn't orbiting the sun, it was diving through its influence like someone trying not to get caught in traffic. The designation 3I means it's the third interstellar object ever confirmed. The I stands for interstellar. Before that, we had the letter C for comets, A for asteroids, and even P for periodic comets. But Oumuamua made us change the rules. It forced astronomers to admit we need a label for things that don't belong. You think about that for a moment, the power of naming something. In ancient cultures, names were sacred. Knowing the name of a god meant holding power over it. Today, naming a celestial object is a way of placing it into order, of making sense of its presence. But when the name itself contains a reminder, Interstellar, you realise that no amount of classification can fully domesticate it. You're still dealing with a foreigner, a cosmic tourist, maybe even a fugitive, and a TLAS. That's not just a name slapped on because it sounds cool. The Atlas project itself is a weird blend of modern software engineering and ancient paranoia. Funded by NASA and operated by the University of Hawaii, it was built to look for the worst-case scenario. Those objects no bigger than a house but capable of turning a city into a bad memory. It's the ultimate last-minute alert system, one designed to give humanity the heads-up it didn't get during the Tunguska event or the Chelyabinsk airburst. And yet, here it is. Instead of finding an earthbound rock, ATLAS finds something possibly older than civilization itself, and far less predictable. This wasn't what it was designed for. It's like programming your thermostat to keep the house warm and finding out one day it detected a ghost. You glance again at the trajectory plotted on your screen. The more refined the models get, the clearer it becomes. This object did not originate in the plane of the solar system. Its angle of entry is steep, almost disrespectful, cutting across the paths of the planets like someone jaywalking through an orbital freeway. It doesn't bend its knee to Jupiter's pull. It doesn't loop around the sun in a nice ellipse. It brushes past and keeps going, like it has somewhere else to be. Historians of science still argue whether our ability to detect these objects is truly new, or whether they've always passed by, silently and invisibly, beyond our instruments' reach. Before Atlas and its siblings like Pan-STARRS, LSST and others, the sky was something we stared at with wishful ignorance. Now, with AI-fed algorithms and all-sky surveys working around the clock, we're finally seeing the flickers in the dark. But it raises a troubling question. Were we really alone before, or just blind? You can't help but think of how the Greek Titan Atlas was punished to hold up the sky. That myth suddenly feels fitting. Because these days, we're trying to do the same, holding up the vastness of the cosmos not with our shoulders, but with silicon chips and mirrored domes, scanning the heavens every second, hoping we catch something before it catches us. And you did. You caught ATLAS. But naming it didn't make it friendly. If anything, it only made it more real. You start to feel the weight of that reality, that something from the space between stars has entered our system. Not in a spaceship, not in a movie, just a lump of whatever, moving at a few dozen kilometers per second, entirely indifferent to the poetry of its name or the minds trying to understand it. There's an odd comfort in that indifference. You imagine Atlas, not the telescope, but the object, as a blank-faced traveller passing through a city without stopping, not looking at the buildings, not reading the signs, just moving. And yet, you're the one watching it from a window, coffee in hand, wondering if you'll ever see anything like it again. And that perhaps is the real mystery. Not just what it is, but how it makes you feel. It's not fear. It's not awe. It's something quieter. A kind of bittersweet realization that the universe is not just full of distant stars, but moving things. Things that slip between the cracks, that enter without permission, that leave without explanation. And we name this one Atlas, the third interstellar visitor, the messenger that didn't speak, the object that reminded us that our sky isn't a ceiling, it's a doorway. You roll over, the blanket twisted around your ankles, and your mind tries to picture the impossible geometry of 3I/ATLAS's path through space. It's hard to imagine something that doesn't orbit anything, because everything you've ever known does. Moons orbit planets, planets orbit stars, stars orbit galactic centres, but this object has slipped the leash. It's what astronomers call a hyperbolic trajectory, and if you plot it on a graph, it looks like a curved exit ramp, one that never reconnects to the freeway. Once it's in, it's already on its way out. This one's entry was particularly dramatic. Coming in at a sharp angle from far below the ecliptic, the imaginary flat sheet where most of the planets hang out, Atlas dove into the inner solar system like someone kicking open a side door at a black tie event. No attempt to blend in, no attempt to stay. You watch the orbital simulation and can't help feeling like you're seeing a crime scene reenactment in space. The red arc of ATLAS cuts across the calm blue loops of the planets like a scratch through a painting. If it were bound by the sun's gravity like a normal comet or asteroid, its path would curve and close into an ellipse. Even if stretched to absurdity, it would still be a closed loop, something predictable. But hyperbolic means the curve keeps going, forever, and the math confirms it. The eccentricity of its orbit is greater than 1. You don't need to be an astronomer to know what that means. It will never return. Not in 1,000 years. Not in 1,000,000. This is a one-way trip. Still, there's something off about this trajectory. Not just the angle or the speed, but how little the object seems to be perturbed by the massive gravitational fields it brushes past. Normally, when a comet swings by Jupiter, its orbit changes dramatically, sometimes even hurling it into the inner solar system or flinging it back out. But a TLAS barely flinches. It glides through Jupiter's domain with the grace of something that's been doing this a long time, like it knows the mass of everything in advance and doesn't need to recalculate. That's not how space rocks usually behave. Or maybe it is, and we're just now noticing the confidence of a truly interstellar traveller. Historians still argue whether earlier flybys, uncatalogued objects seen once and lost, might have been similar visitors. Did we miss a dozen atlases in the past 100 years? 100 in the past 1,000? You find a quote drifting through your half-awake mind. Something Carl Sagan once said, "The universe is not required to be in perfect harmony with human ambition," which is a nice way of saying, just because you want something to make sense doesn't mean it will. And so, the more you examine this orbit, the more questions it raises. How did a TLAS reach such velocity? Interstellar space is not known for its excitement. Most things that leave their star systems do so with the sluggish sadness of exile, not with the determined angle and haste this object shows. You do the math again in your head. It's moving at around 26 kilometers per second relative to the Sun, about the speed needed to escape our solar system entirely. But that's just now, which means when it first crossed into our local patch of space, it was going even faster. To have that kind of momentum, a TLAS must have been flung, not gently ejected, not accidentally drifted, but hurled. You picture a dying star system, planets colliding, suns expanding, entire belts of debris tossed like confetti into the void. Maybe a TLAS was part of that. Maybe it's a piece of something long gone, a survivor, or a refugee. There's a hypothesis known as stellar ejector theory. It suggests that most interstellar objects are flung out of their systems during the chaotic early days of planetary formation, when Jupiter-sized giants migrate inward, playing gravitational billiards with everything around them. Debris gets kicked out into deep space, never to return. Some of it wanders for billions of years, some of it collides with other systems, most of it just drifts. Until one day, a tiny fraction finds its way into a telescope's field of view. Still, there's an unsettling possibility. What if Atlas didn't come from one of those chaotic systems? What if it came from a quiet one? A stable star with calm, circular orbits and nothing but time. In that case, its ejection wouldn't be natural. It would be deliberate. That's the sort of thought you immediately try to smother with science, and yet, even the data doesn't entirely behave. The object's velocity doesn't match predictions exactly. Minor deviations, residuals, as though something tiny, imperceptible is nudging it. Non-gravitational forces, outgassing, possibly. But no one's detected any visible gas. No dust, no coma, no tail. Just motion. Motion with an attitude. Remember that orbital model from section 2? The one that looked like a skipping stone? You revisit it now, this time more critically. It doesn't look like a random entry anymore. It looks like a trajectory with intent, and that's a dangerous place for your imagination to hang out. Fringe theorists have already pounced on this. They point to the shape of the orbit, the smoothness of the curve, the timing of its discovery. They ask, why are we seeing these things now? Why not in the 1800s? Or the 1500s? One especially poetic theory suggests that we're catching these visitors because they want to be caught, because we finally have the technology to notice. But that presumes a lot. That presumes consciousness. That presumes design. It's easier to say it's a rock, a weirdly moving rock, from somewhere we've never been, travelling in a hyperbolic arc that guarantees it won't come back. But then again, so did Oumuamua. And look how long that debate lasted. You try to picture the moment ATLAS entered the solar system. No fireworks, no soundtrack, just a lonely speck, far from anything warm, making its silent approach. No audience, no applause, just physics. Pure, dispassionate physics until we spotted it and gave it a name that means weight, pressure, burden, Atlas. Maybe we're the ones carrying that burden now. You close your eyes, just for a second, and when you open them again, you're still thinking about the silence, the way 3I/ATLAS glides through the solar system without fanfare, without a tail, without the dramatic outgassing we've come to expect from long-period comets. You were told comets are dirty snowballs, icy, volatile-rich remnants from the dawn of the solar system that flare up spectacularly when sunlight hits them. But this one? It just doesn't play along. No coma, no tail, no shimmering halo of gas and dust. It reflects some sunlight, yes, but not enough to light up like a comet. You wonder, what even is it? Is it an asteroid? A fragment? A shard of some ancient body, long dead and cold beyond recognition? Or is it something entirely new? An object that sits somewhere between classifications, too warm for ice, too smooth for rock, too foreign for comfort. Astronomers call it a non-active body, which is a fancy way of saying it's not doing anything helpful to make their jobs easier. No jets of gas to analyse, no dramatic flares to chart, just a quiet, steady point of light moving far too fast and far too straight to be local. It's like trying to identify a bird by the shape of its shadow on a foggy morning, and the bird, just to mess with you, doesn't flap its wings. And that's what makes 3I/ATLAS especially frustrating. It's not that it is mysterious, it's that it refuses not to be. With Oumuamua, there was the same issue. It didn't outgas like a comet, but it did accelerate slightly, just enough to spark fever dreams of alien probes and light sails. Borisov, on the other hand, was comfortingly familiar. It had a tail, a coma, a clear composition. It behaved like a comet from our own system, just with a different origin story. But ATLAS. Atlas splits the difference, and then sidesteps the question entirely. You sit there, blinking at brightness graphs and reflectivity curves, trying to read between the data points. There's this nagging, persistent inconsistency. The way light bounces off the object doesn't quite match a smooth surface, nor does it match a rough, porous one. It's inconsistent. Some nights it flashes brighter, other times it dims. There's no reliable pattern. The spin rate is ambiguous. The light curve, normally used to estimate an object's shape and rotation, flickers like static, as if the object is tumbling maybe, or shifting in ways we don't understand. And then there's the colour. It's darker than expected, absorbing more light than it reflects. Not black exactly, but certainly not gleaming. Scientists suspect its surface is coated in carbon-rich compounds, the kind that tend to build up over eons in the cold darkness between stars. That would be typical. But something about the reflectivity, the albedo, just doesn't sit right. It's too flat, too uniform, like the whole surface has been processed or altered somehow. Weathered, maybe, but by what? Out there, in interstellar space, there's not much weather to go around. That's when one of those fringe ideas floats back into your mind. What if it's artificial? You don't want to go there. You really don't. But the thought, like a mosquito in a quiet room, just won't leave you alone. Because if something were designed to drift silently through space without giving off heat or gas, it might look an awful lot like this. Of course, mainstream astronomers roll their eyes at this kind of speculation, and fair enough. We've only had 3 confirmed interstellar visitors. It's not a statistically robust sample size, but even among that tiny club, ATLAS is the strange one. Borisov gave us water vapour and cyanide and carbon dioxide. Oumuamua gave us puzzles and arguments, but ATLAS, it's giving us nothing. Just a glint, a shadow, a steadily moving point that refuses to give away its secrets. And yet the longer you look at it, the more it feels like a silence that's hiding something, not necessarily in a spooky alien way, but in that annoying scientific way where the data doesn't fit the models, and the models don't explain the behaviour, and the behaviour makes people very uncomfortable because, let's face it, science prefers boxes, neatly labelled, categorised boxes. Atlas refuses the box. Some researchers have suggested that ATLAS might be a fragment of a larger object, something that broke apart long before entering our system. That would explain the weird shape and alike behaviour. Maybe we're not looking at a single body, but a loose clump like a cosmic dust bunny, loosely held together by inertia and spite. But that raises other problems. If it is a fragment, where are the others? Why haven't we seen them? Where's the rest of it? Historians of astronomy often remind us that most great discoveries come from anomalies, things that don't fit. Uranus was discovered because it moved wrong, Neptune because Uranus moved wrong, Pluto because, well, okay, that one didn't hold up so well, but the point still stands. When the universe surprises you, you pay attention, and 3I/ATLAS. It's surprising everyone. Meanwhile, some researchers have begun building thermal models to test whether it could still be outgassing, just in a way that doesn't produce visible effects. They suggest it might be leaking gas slowly, evenly, in all directions. So evenly that there's no noticeable thrust or visible tail, like the world's most passive-aggressive comet. This kind of behaviour has been seen once or twice before. Oumuamua was a candidate for this kind of low-key isotropic release. But with ATLAS, there's even less to go on. No detected volatiles, no spectroscopic signature, just that motion. A few especially adventurous theorists have pointed out how similar this all sounds to some of the speculative probes designed by human engineers. Sleek, dark objects with minimal surface features, capable of drifting undetected through hostile environments. Again, that's not proof of anything, but it is eerie. Still, the leading consensus, so far, is that ATLAS is likely natural. An unusually inert fragment of something larger, maybe a piece of a long-dead planet, maybe a lonely shard of an ice ball that got flung into the void during the formation of a binary star system. No signal, no structure, no agenda, just a lump of interstellar debris, cold and quiet and old. But even the natural explanation doesn't erase the wonder, because even if it's just a rock, it's a rock from somewhere else, not from Mars, not from the asteroid belt, not from the Kuiper belt or even the Oort cloud. This thing, whatever it is, formed in a place your species has never seen. It bears the signature of an alien sun, alien gravity, alien history. You may never know its true origin, but you do know this. It's not from here. And that's enough for now to keep your eyes open a little longer. Your head sinks deeper into the pillow, but your mind's doing laps now, tracing orbits that no planet dares follow. Because 3I/ATLAS, for all its silence and shade, has echoes of a story you've heard before, one that came with a lot more drama, a lot more confusion, and a lot more late-night telescope arguments. You know the one. Everyone knows the one. The first guest to arrive unannounced, 1I/Oumuamua. You remember how it all unfolded. The news came fast, as it always does, an elongated blip caught moving too quickly for comfort. Then came the media circus, the whispers, the lectures, the think pieces, the scientists who muttered about radiation pressure and outgassing, and the scientists who muttered back, what outgassing, and the ones who just pulled the blinds and went back to their simulations. Oumuamua was uncooperative. It entered from above the solar plane like Atlas, and zipped past the sun before anyone knew to look. By the time the telescopes were pointed at it, it was already on its way out, flashing its light curve like a middle finger. Observation showed it was tumbling chaotically, with a brightness that varied in a way no one could quite explain. That led to all the shape theories, the cigar, the pancake, the weird shard of metal hurtling through space guesswork that felt more like art class than science. And like Atlas, Oumuamua refused to play fair. It had no coma, no visible outgassing, no tail, just that odd little push. It didn't accelerate much, but it did accelerate slightly, in a way that shouldn't happen without some kind of jet or vent or leak. Scientists tried to explain it with sublimating ice. Others thought maybe it was hydrogen ice, something fragile that evaporated without leaving a trace. But then came the calculations. If it were made of hydrogen, it wouldn't have survived the journey. Too delicate, too exposed. The sun would have cooked it. Interstellar radiation would have eaten it alive. Historians still argue whether Oumuamua was an example of a new class of object or just a case of really, really bad timing. We never got a close-up, never saw its surface. It came and went before the big telescopes could even coordinate. Some called it a failure of preparedness, others a gift, proof that we were finally capable of seeing such fleeting things at all. And somewhere in the middle of all that, people started whispering the word. Alien. It started subtle. Just a mumbled possibility on Reddit. A raised eyebrow in a podcast. A a strange comment in a peer-reviewed paper from a Harvard professor who'd clearly had enough of everyone else's icy fragment hand-waving. That professor, Avi Loeb, made headlines by suggesting Oumuamua might be artificial. A light sail, perhaps, drifting through space. Not a spaceship exactly, but the debris of one. The dead skin of a craft meant for something bigger. A breadcrumb on a galactic trail. A messenger, or maybe just a message. We were here. Of course, the pushback was immediate. Astronomers aren't exactly known for jumping on speculative bandwagons. They prefer their data cold and their conclusions colder. But Loeb didn't back down. In fact, he leaned in, wrote a whole book about it, founded a research initiative, argued loudly that we were missing the obvious. Not everyone agreed. Most didn't. But what stuck with people was the tone. The idea that we shouldn't dismiss the unusual just because it makes us uncomfortable. That maybe, just maybe, the universe wasn't playing a game of hide and seek. We were just too busy looking under the wrong rocks. And now you're lying there, blinking up at the ceiling, thinking how similar 3I/ATLAS feels to that first scout. The same quiet entry, the same mystery motion, the same refusal to conform to what a comet or asteroid should do. If Oumuamua was the scout, what is ATLAS? A second probe? A sibling? A coincidence? You try to resist the pull of the pattern. Your logical brain starts piping up, reminding you that interstellar space is filled with debris, that solar systems eject billions of objects during formation, that these things should be common, even if our instruments are only now good enough to see them. But then again, common doesn't mean boring. An atlas, like Oumuamua, just won't shut up. Not verbally, of course. It's silent as stone. But the numbers keep nudging. The trajectory is clean. Too clean. The brightness doesn't vary the way it should if it's spinning. The absence of a tail continues to be a problem. Some researchers are wondering if maybe it's rotating on more than one axis, tumbling in a complex, chaotic motion, the way Oumuamua was. If that's true, it would explain some of the odd light patterns, but not all. Others are probing deeper. One recent theory proposes that Atlas could be covered in a dense carbon-rich layer, an interstellar sunburn, essentially, where cosmic rays and micrometeorite impacts have altered the surface into a dark, non-reflective crust. That would explain its lack of visible outgassing, perhaps. Maybe any volatiles it once had have already sublimated off during its long journey through the void, leaving a brittle husk behind. But again, this isn't confirmation. This is guesswork. Best-case modelling. Educated shrugs and simulations run on university supercomputers in the middle of the night. There's still no image of the object beyond a faint dot of light. We don't know its true shape. We don't know its mass. We don't even really know its origin, only that it's not from around here. And that's what ties it all together. Oumuamua, Borisov, Atlas. You can't help but feel like they're part of a sequence, like the universe has started clearing its throat. First came the stranger that whispered but didn't stay, then the visitor who acted normal but looked foreign, and now the one who walks through quietly says nothing and leaves you wondering if they were real at all. You remember an old fringe idea, one of those science fiction tropes that sneaks into serious conversation when the numbers run dry. The idea that advanced civilizations might send inert, unpowered objects into the universe to drift indefinitely. Not ships, not probes, just dead messengers, space boys, dark beacons, not meant to communicate with us directly but to be found, to say yes, someone else existed. You sigh, roll over again. Maybe it's nonsense. Maybe Atlas is just a rock, a quiet, dark rock from nowhere in particular. But if so, it's a rock that's managed to draw the attention of every major observatory on Earth. A rock that refuses to act like one. A rock that echoes another rock that, just a few years ago, upended everything we thought we knew about the silence between stars. And the silence? It's still there, still humming, still waiting. You try to settle your thoughts, letting them drift with the same indifferent pace as 3I/ATLAS, but your mind keeps looping back to one icy name, Borisov, the second interstellar visitor, the middle sibling in this strange cosmic trio, and compared to the maddening elusiveness of Oumuamua and the unsettling silence of Atlas, Borisov was kind of a relief. If Oumuamua was the cryptic whisper and Atlas is the mute stare, Borisov was the one that walked in, introduced itself and said, "Hi, Yes, I'm from another star system, and here's my paperwork. Discovered in 2019 by amateur astronomer Gennady Borisov from a backyard observatory in Crimea, 2I/Borisov was immediately flagged as something special. It was obvious from the start. Its speed, trajectory and angle of approach made it clear it didn't come from around here. But unlike Oumuamua, Borisov behaved. It acted like a comet. It even looked like a comet. A bright nucleus, a glowing coma, a long tail that fanned out as it drew near the sun. Scientists practically wept with joy. Finally, an alien, but one we could understand. But now, as you lie there thinking about Atlas and the empty silence it drags behind it like a forgotten coat, Borisov suddenly doesn't seem so normal anymore. Sure, it checked all the comet boxes, but it still had its quirks. You remember reading that it had unusually high concentrations of carbon monoxide, far more than typical solar system comets, and not just a little more, it was rich, like suspiciously rich. Astronomers wondered what kind of cold, chemically lush nursery could have produced it. And then there was the dust, lots of it. Borisov shed material at an alarming rate, far more than expected, creating a tail so dense it sometimes obscured the comet itself. Some researchers estimated it was crumbling even before it got too close to the sun. It was fragile, brittle in a way that suggested it hadn't been through this kind of journey before, a first-time flyer. Which raised a question. Was Borisov fresh from its home system, a newly ejected fragment? Or had it been drifting through interstellar space for ages, perfectly preserved in cold, only to fall apart the moment it reached the warm breath of our sun? Historians still debate that timeline. Some say Borisov had been wandering for tens of millions of years. Others argue it could have been billions. After all, interstellar space is the universe's junkyard. Old things drift there, forgotten for epochs. But if Borisov really had been travelling that long, its fragility was confusing. Why didn't it erode? Why didn't cosmic radiation strip it down to dust? One fringe theory posits that Borisov had only recently been ejected, perhaps by the violent rearrangement of giant planets in another solar system. Imagine a massive gas giant nudging a comet just right, flinging it with precision past the gravitational edges of its star, letting it slip free like a stone launched from a cosmic slingshot. That's the kind of speed Borisov had, and its speed was impressive. It came in hot, about 32 kilometers per second, just fast enough to make a quick loop around the sun and keep going, never to return. You watch the path in your mind, in, around, and out again. No hesitation, no loops, just a perfect hyperbola. And yet, unlike Atlas, Borisov made itself known. It gave us data, spectra measurements, proof. It even let us taste it, in a sense. Through high-resolution spectroscopy, astronomers detected the chemical makeup of its coma: water, carbon monoxide, hydrogen cyanide, dust particles, the kinds of materials you'd expect in a primordial comet, but different in ratios, different enough to tell us this was not one of ours. It was like peeking inside someone else's pantry and realizing they bake their bread entirely differently. Same basic ingredients, wildly different recipe. And still, Borisov never stuck around long enough for a full study. By the time we scrambled our telescopes, ground-based and orbital, it was already fading. The moment it slipped away, the regret started. If only we'd had warning. If only we'd had a fast response probe. If only we'd known what to look for. That regret lingers now as 3I/ATLAS cuts its own line through the sky. Another chance to observe, another opportunity to understand, but Atlas isn't cooperating. Where Borisov bloomed, ATLAS is dim. Where Borisov cracked and shed its secrets, Atlas holds itself together with stubborn resolve. No coma, no tail, no splash, just a dot, cold, aloof, unmoved. And yet, you can't shake the idea that the comparison matters, that seeing Borisov gave us a baseline, a kind of interstellar Rosetta Stone. Because now we can say, this is what a normal alien comet looks like. And if Borisov is the control group, then Oumuamua and Atlas are outliers, each in their own strange, quiet way. Some scientists have even started to suggest that there may be two, or more, classes of interstellar visitors: the fluffy, gassy, comet-like ones like Borisov, and the hard, dense, mostly inert ones like Atlas and Oumuamua. The idea being that the early solar systems that eject these objects also create them under wildly different conditions. Maybe Borisov came from the icy outer shell of a gas giant system. Maybe Atlas and Oumuamua came from shattered planetary crusts, remnants of collisions, objects too old and dry to weep. It's a compelling idea that we're slowly building a taxonomy of extrasolar rubble, that we're beginning to read the ancient geological record of stars we've never even seen. With every visitor, the dictionary grows. The alphabet of the void starts to take shape, but there's something else, something in your gut maybe. A feeling that, if you could just get close enough to ATLAS, you'd find it wasn't like Borisov at all, not even close. Borisov came with storylines, substance, signals, hints. Atlas is withholding, not just quiet, but closed, as if it knows it's being watched. Or maybe it doesn't. Maybe it just doesn't care. Still, you can't help but imagine what it would be like to reach one of these objects, to actually send a probe, to fly beside it, to see the surface with your own eyes, smooth or pitted, dark or gleaming, intact or crumbling. What would you find? Ice? Metal? Carved lines? A signature? A fingerprint? No one's ready to say. Not yet. But the wish is there, stronger than ever, because Borisov gave us a taste, and a TLAS. It's offering the menu but keeping the kitchen locked. The longer you watch 3i/ATLAS glide through its cold, indifferent arc, the more your mind clings to what isn't there. The silence is one thing. The lack of a coma, the refusal to shimmer or melt, the stubbornly dark surface, those are all unsettling in their own quiet ways. But now something else nags at you. Something subtle. A ghost in the data that's either trying very hard to hide or doesn't care enough to be noticed. It's the shedding. You squint at the most recent observations, distant telescopes logging its dim flicker against the black, measuring changes in brightness so minute they seem almost petty. But there's something in the readings, an irregularity, a faint dip here, a brightening there. Not enough to suggest a tail or a gas jet or even a consistent rotation. Just crumbs. A little bit of light here, a little more over there, like Atlas is losing something. Or leaking. It's not outgassing exactly. Nothing you'd call a typical cometary process. There's no visible plume, no whisper of ice vaporizing into the void. But still, some researchers are starting to wonder, is a TLAS falling apart? Or is it just pretending to? This is where the theories start to spiral. First slowly, then exponentially. Because if Atlas is fragmenting, that could explain the fluctuations. A loose hunk of material could drift off, rotate, reflect sunlight differently, then vanish into shadow. Simple physics, clean explanation, probably the truth. But then someone adds, what if it's intentional? What if we're witnessing controlled disintegration, or cloaked emission? You want to laugh at that because that's not how science works. Except that's exactly how science starts. Someone notices a twitch in the data, then someone else refuses to explain it away. And before long, you're neck deep in conference abstracts that read like campfire ghost stories. Except the ghost is a chunk of rock from another star, and no one knows what it wants. Historians of science are quick to remind people, data isn't neutral. It's always filtered through the questions we're asking. And right now, the question being quietly asked in observatories, back channels, and very late-night Zoom calls is, what is this thing doing? The models are diverging. Some suggest ATLAS is shedding loosely bound material, a sign of internal weakness. Others argue that it's simply rotating in a way that presents different reflective surfaces over time, giving the illusion of material loss. Still others whisper that maybe we're seeing something more organized, a structural failure with patterns, edges, planes, lines. Of course, those last whispers are not well received in polite scientific company. Nobody wants to be the person who jumps straight to alien technology when there's still a perfectly good boring rock explanation on the table. But the more people dig into the photometric light curves, the more the straight lines seem to blur. Even the big names are hedging their bets. You see the word anomalous start to creep into technical papers. A few too many phrases like inconsistent with standard comet behavior and requires further observation start piling up in abstracts. Translation, we don't know and we don't want to guess wrong. Again. Because let's not forget, we guessed wrong with Oumuamua. At first, everyone assumed it was a comet, then an asteroid, then a comet again but with secret hydrogen. then maybe a thin sheet of something exotic. And just when people were starting to settle on boring rock with commitment issues, someone proposed it could be the splintered remains of a light sail, a spacecraft, or more precisely a spacecraft skeleton. That theory never quite died. It just quietly receded into the shadowy corners of scientific discourse, where words like speculative live next door to career ending. But Atlas isn't letting anyone off easy. Its lack of clear activity means we can't fall back on typical comet models, and its path is too clean, too perfectly hyperbolic for it to be anything but interstellar, so we're left with these whispers of fragments, of dust, of missing mass, and no explanation that doesn't come with a little unease. One astronomer floated a theory that ATLAS might be covered in a crust of refractory material, a shell formed by millions of years of cosmic radiation hardening the surface, sealing in volatiles that now refuse to escape. That would explain the lack of visible outgassing. It would also explain why, if it's breaking apart, it's doing so quietly, slivers sloughing off like the skin of an ancient fruit left too long in the cold. But then you wonder, is it only breaking apart now? After 1 billion years of floating between stars, ATLAS waits until it reaches our system to start shedding pieces. That timing feels convenient. Too convenient. Some speculate this could be due to solar heating. After all, it's closer to the sun now than it's been in eons. Thermal expansion, stress fractures, simple mechanics. That's what the models suggest. But you can't shake the image. Atlas moving through space, losing little bits of itself like it's dropping clues, or messages, or maybe just decoys. One particularly eccentric paper, quietly retracted a week after posting, suggested that ATLAS could be a kind of data capsule, something meant to erode slowly, releasing material at pre-planned intervals. Not fast enough to be noticed by casual observers, but just enough for a civilization with the right instruments and timing to notice. You stared at that paper longer than you should have. Because while that theory might be far-fetched, the core idea that this object isn't just here but behaving feels harder and harder to ignore. And that leads to another question, one that feels too large to ask but too loud to dismiss. What if we're not observing ATLAS? What if ATLAS is observing us? You don't mean that in a spooky sentient probe kind of way, just, what if its passage through the solar system is strategic? If someone wanted to study this little star system from afar, what better way than to toss in something that doesn't seem to belong, let it drift and watch what the locals do? You think about all the telescopes turning to face this object, the satellites, the supercomputers, the humans watching with wide eyes. We are, without question, paying attention. And perhaps that's the point. Maybe that's the only goal. Leave something ambiguous enough that the observers can't look away, whether it's crumbling from age or playing some unintentional game of hide and seek. Atlas is succeeding in a way few objects ever have. It's holding the attention of a species that usually forgets things between breakfast and lunch. So now you're watching for more than light. You're watching for shadows, patterns, the shape of what's missing. Because sometimes the gaps say more than the pieces we can see. And ATLAS, it's saying something, even if it never says a word. You lie there, half wrapped in a blanket, staring into nothing, and that number floats back into your mind again. 60%. Not 100, not 50, 60. That's the latest informal consensus emerging from a swarm of orbital modelers, spectroscopists, and sleep-deprived graduate students blinking at Atlas's trajectory over cheap coffee, and a growing sense of existential dread. A 60% chance. But of what, exactly? It started as a comment in a quiet Zoom call. Then someone else ran the numbers. Someone else re-ran them using a different model. Within a week it made its way into internal memos and private forums. Not published, not peer-reviewed, not anything anyone could be quoted on. But the phrase stuck. There's a 60% chance something's off with this one. Now you don't have to be an expert to know how rare that kind of phrasing is in astronomy. This isn't a field known for gut feelings. Astronomers live and breathe in decimals and sigmas and tolerances. They don't say things like, "This feels weird." They say, "There is a 0.0001 variance inconsistent with expected orbital decay." But this isn't a decimal place. This is a shrug dressed up as a statistic. A 60% chance that what we're seeing doesn't match what we think we should see. You roll that number around in your head like a marble in a bowl. It's not high enough to scream certainty, it's not low enough to dismiss. It lives in the weird, twitchy space between comfort and curiosity. Enough to make the mainstream nervous, enough to make the fringe energized. The number itself stems from a growing mismatch between observations and the expected physical model. The orbital path is too precise. Atlas glides through the solar system like it rehearsed this route. There are no major gravitational perturbations, no signs of chaotic scattering. It doesn't wobble the way loose rubble might. There's also that troubling photometric consistency, a nearly featureless light curve that somehow still fails to match anything typical. The reflectivity changes, yes, but not in a way that correlates with spin or shape in any model we trust. It's as if the object knows how to confuse our instruments, or more rationally, as if we're looking at something that doesn't conform to the behaviours we're used to cataloguing, like a tone-deaf singer standing in the middle of an orchestra. The phrase non-gravitational acceleration keeps cropping up, and with it comes a nervous shuffle. That term lit fires when used with Oumuamua. It suggests movement that can't be explained by gravity alone. In that case, the culprit was assumed to be a very subtle pressure, likely from outgassing. But here, in Atlas's case, there's no confirmed gas. No push, just drift. Some researchers argue it might be experiencing a Yarkovsky effect, that tiny force created when sunlight heats one side of an object, and the resulting radiation gives it a gentle nudge. This happens with small asteroids all the time, but for that to apply here, Atlas would need to be spinning a certain way, have a predictable surface, and be absorbing and re-radiating heat just so, and it isn't. At least not according to the data we've scraped together so far. You remember one especially cranky theorist on a late-night radio program comparing ATLAS to a billiard ball with opinions. It's like you hit it with a cue stick, and instead of bouncing, it rolls off the table and writes a poem. That image sticks with you. This silent, distant object moving not chaotically, but elegantly, almost deliberately. And that brings us back to that squishy, discomforting 60%. 60% isn't proof, it's not even a consensus, but it is a signal, an admission that maybe the tools we have aren't enough, or that the assumptions we're bringing to the table aren't valid anymore. You feel the pull of that idea, the way it challenges the way you've always thought of the solar system, as a mostly quiet place with well-behaved rocks and predictable physics. But what if that's not true anymore? Or worse, what if it was never true and we're only just now learning to listen properly? You glance at a thermal map of ATLAS's projected path. It moves like a ghost across the screen, never flinching. One pass through the inner system, then gone. It won't slingshot. It won't loop back around. It won't even hang around long enough to be photographed in real detail. Like Oumuamua, it's here and then it's not, and we'll be left with data tables and regrets. One astronomer you follow online, someone normally allergic to anything speculative, posted a thread simply titled 60% Chance of the Unexpected. It was half joke, half confession. In it, they described the unusual consistency in ATLAS's brightness, despite angle changes, the minor deviations in speed that don't match gravitational predictions, and the way its thermal signature didn't shift as expected. Their conclusion? We're either misreading something simple, or we're looking at something we've never seen before. Either way, I'm not sleeping well. You are, ironically, trying to sleep, but Atlas won't let you. The sheer otherness of it all lingers like a cold breeze. You think back to that number again, 60%. It's enough to suggest the odds are no longer in favour of business as usual. It's a soft drum beat, not a siren, not a roar, just a steady knock at the door. And you're not the only one who hears it. SETI researchers have started passive scans, just in case. Not active pings, not broadcasts, just listening. Radio dishes tuned to the space around Atlas as it passes through, looking for any signal that might suggest deliberate transmission. So far, silence. But the effort is still happening, and that effort speaks volumes. Because even a whisper of the unexpected is enough to shift priorities. Even a 60% chance that we're looking at something anomalous is enough to make people start asking the kind of questions you only ask when the old answers stop working. What is a TLAS? Where did it come from? What is it doing? And the one that's hardest to shake, why now? You lie in the dark and feel the shape of those questions pressing against your skull like pressure from the inside out. Because 3I/ATLAS is not just a thing in the sky. It's a mirror, a test, a riddle so clean it almost feels artificial. A question asked in the language of motion and silence. And now the whole world, at least the part of the world still awake at this hour, is trying to answer back. 60% isn't proof, but it's enough to change the conversation. And maybe that was the point all along. You rub your eyes, blinking away the glow of your screen, and somewhere between drowsiness and curiosity, you start sketching it out in your mind. 3. I/ATLAS, the object itself. What does it actually look like? Not the blurry pixelated speck seen through some 1,000-mile stare from an Earth-based telescope, but the real thing. The surface, the shape, the texture. If you could fly right up beside it, hand hovering just inches away, what would you see? Here's the thing. No one knows. Not really. But that hasn't stopped the speculation machine from spinning itself into oblivion. Based on the brightness variations, what astronomers call the light curve, there's been some attempt to reconstruct ATLAS's shape. You'd think with enough frames and fancy math we'd have a good guess. But the data in this case is maddeningly unhelpful. The object's reflectivity varies over time, yes, but inconsistently. Some suggest it has a long, narrow profile, like a cigar. Others swear it's wide and flat, more like a cosmic pancake spinning through the dark like a coin flipped by some interstellar gambler. A few daring voices have suggested something even weirder, that ATLAS's shape is changing. Not transforming like a sci-fi spacecraft mid-flight, but breaking down, rotating irregularly, revealing different angles over time. Fragments could be coming loose, or the object itself could be composed of a loose aggregate, a rubble pile. That would explain the flickers in brightness and the lack of a stable spin signature. But it also suggests Atlas isn't long for this universe. You imagine it now, a slow-rotating polyhedron, faceted and ancient, its surface dusted with the scars of eons. Maybe it's irregular, sharp-edged. Maybe it has impact craters from long-forgotten collisions. Or maybe, disturbingly, it's smooth. Too smooth, as if it's been made that way. You hesitate with that thought, but it keeps coming back. Because a smooth shape in space is unnatural. Entropy creates chaos, roughness, brokenness. Comets and asteroids alike are battered, pitted, misshapen. Their surfaces reflect their violent histories, but Atlas's light curve doesn't match any of that. Instead, it reflects as if from consistent planes. Shifting, yes, but without the rugged, chaotic pattern you'd expect from a natural hunk of interstellar debris. Some simulations have tried to model it as a tumbling shard, a long plate-like object rotating along multiple axes. That's how scientists try to explain Oumuamua's light curve too. The cosmic pancake hypothesis stuck around for years. A flat, elongated slab maybe 10 times as long as it is wide, flipping and twisting as it sails past the sun. It fits the data, barely, but it doesn't sit well, because the universe isn't known for making pancakes. Historians still argue whether Oumuamua's shape was truly unique, or simply appeared that way due to observational limitations. Was it flat? Long? Was it reflecting unevenly due to a strange surface composition? Or was it just a rock playing tricks on our instruments? We may never know. And now here comes Atlas, another shapeshifter, another echo of confusion. We haven't gotten close enough to image it directly. There's no spacecraft en route, no high-resolution radar scan, just photons bouncing off a mystery. The colour is odd too. Observations place it in a very dark range, what astronomers call low albedo. It reflects less light than asphalt, darker than coal. It absorbs most of what hits it. A surface like that tells a story, if we know how to read it. It suggests exposure to cosmic rays over unthinkable distances and times, radiation breaking down ice, stripping atoms, leaving behind long carbon chains, black as ancient soot. That's the mainstream view anyway, a sunburned interstellar traveller, its surface charred by the cold fire of the void. But others wonder, what if it's coated deliberately? If you wanted to reduce your visibility in space, not for stealth, but for heat regulation or shielding, you'd use dark materials. You'd absorb energy instead of reflecting it. You'd avoid drawing attention. You'd look a lot like ATLAS. Again, the rational voice in your head pushes back. Occam's razor. It's just a weird rock, but every time the data rolls in, the shape gets fuzzier, not clearer. Each new reading unearths more ambiguity, and ambiguity in science is like blood in the water. It attracts both the serious thinkers and the wide-eyed theorists. The debate over its spin adds another layer of weird. A standard asteroid or comet spins on a single axis, maybe wobbly but generally predictable. But ATLAS, its light variations suggest a chaotic rotation, perhaps even a tumble. Some say it could be a non-principal axis rotator, a fancy way of saying it's not spinning normally. Imagine a screwdriver tossed through the air. It doesn't rotate neatly, it spirals in a way that defies easy modelling. But even that doesn't fully explain what we're seeing. If it were just tumbling, the light curve should stabilise over time. It hasn't. If anything, it's become more erratic. That's not how nature works, unless something's constantly interfering, or the structure is unstable, or both. There's a fringe idea, a newer one, rarely voiced aloud, that ATLAS might be hollow. Not hollow like a shell, but like a fractured container. A shell cracked open on one side, a husk. That theory was laughed off when suggested for Oumuamua, but the shape and spin inconsistencies match. Barely. You imagine a broken bell tumbling through space, echoing nothing but silence. You glance at a simulation someone made, just a speculative 3D model based on the math. It's an irregular shape, angular, almost crystalline, not jagged but faceted, a prism caught mid-spin. It's not proof of anything, of course, but it doesn't feel random either. It feels like a geometry born from intention, or at least from something more complex than impact damage. Could it be an ancient fragment of something larger, a planetary shard, a sliver of a broken moon? Some ancient cataclysm flung a piece of crust into space, and now here it is, drifting through our solar system, too old to remember where it came from. Or was it not broken at all, but built this way? You find yourself turning the question over slowly. What does something designed to drift for 1 billion years look like? Probably not sleek, probably not shiny. It wouldn't need fins or engines or blinking lights. It would just need durability, simplicity, intent. Maybe it would be shaped not for function, but for longevity. And maybe, just maybe, it would be shaped in a way that avoids easy classification. And that's what you're left with, a shape that refuses to be known. Atlas doesn't spin like a comet, doesn't shine like an asteroid, doesn't fit the models, doesn't give up its form. It just glides, faceless, and lets you project your thoughts onto it like a shadow puppet against the dark. Maybe that's the point. You roll onto your back, staring at the ceiling like it might open up into space, and you think, if it isn't a rock, and it isn't ice, and it isn't just random debris, what's left? You're not trying to jump to conclusions, not really. You're just listing possibilities, methodically, carefully. The way scientists do, even when those possibilities start to feel more like the opening crawl to a sci-fi movie than anything you'd expect to hear in a faculty lounge. Because here's the whisper, the one that started with Oumuamua and returned with Atlas. The theory that hangs on the edge of respectability like a conspiracy theorist at a science conference, sipping bad coffee and waiting for someone to ask the right question. What if it's not natural at all? There it is. You've said it. Quietly. To yourself. So the stars don't hear. Artificial. Manufactured. Engineered. You don't have to believe it to entertain it. That's the key. Science begins with questions, not answers. And this one has started popping up again. Cautiously, carefully, sometimes under a pseudonym, in papers, talks and late-night Slack channels. Because if 3I/ATLAS isn't a typical comet or asteroid, then what is it? We're not talking spaceships here. No glowing engines, no antennas winking at us from 1,000 astronomical units away, no elegant curvature or blinking blue panels. If this is artificial, it's old, broken, lost, a ghost. And ghosts don't announce themselves. They drift, they confuse, they get mistaken for shadows. You remember the theory from 2018, one that got more laughs than headlines, that Oumuamua could be the shattered remains of a light sail. A propulsion system designed to ride the pressure of starlight across impossible distances, the kind of tech we're just now imagining. Loeb and others suggested it wasn't the whole ship, just debris, space trash, a fallen leaf from someone else's tree. That idea was mocked, of course, dismissed as overreaching, but the truth? No one proved it wrong, they just buried it under more likely possibilities until the noise faded. But now, with ATLAS, the same whispers are coming back. Some of it's based on the trajectory, the weird, deliberate arc, the way it cuts through the solar system without reacting much to gravity, almost like it's plotted. not curved by influence but charted, navigated, at least once, long ago. Then there's the surface, too dark, too uniform. That carbonized crust could be the result of billions of years of cosmic radiation, or it could be something else, something designed to protect or preserve. Even more troubling are the spin anomalies. The strange rotational behavior could be natural, sure, but it also looks eerily like a body that's been damaged, unbalanced, like something once symmetrical, now off kilter. A broken stabilizer, a cracked frame, something that used to rotate cleanly. Historians still argue whether humanity is even ready to spot artificiality in space. If we found it, would we recognize it? Or would we mislabel it, fold it into the comet category, sigh with relief, and move on? That's what gnaws at you. Maybe we've seen dozens of artificial objects, fragments, shells, failed probes, mistaken for natural bodies because they didn't look like what we expected. And who are we anyway to define alien engineering? If they came from a water-world civilization, would their artifacts be metal or mineral? If they evolved in high radiation environments, would their structures even resemble machines? Or would they look like natural debris, intentionally? Perhaps stealth, in the void, looks like irrelevance. You don't hide from predators, you hide from analysis. And what better way to slip past the attention of a young, noisy species than to enter as a rock? It's not like we're blind to the idea. SETI's been listening for decades. We've scanned radio bands, looked for patterns, waited for beacons. But maybe beacons aren't the way it works. Maybe the messages aren't light. Maybe they're objects, silent, enduring, data-bearing, or simply watchers. Think about it. A planet-bound species reaches a certain level of technology. It starts to scan the sky. Suddenly, interstellar objects begin to arrive, one every few years, small, harmless, mysterious. Nothing too obvious, but just enough to get noticed, enough to provoke study, debate, obsession. That's the theory floating now in certain corners of the astrophysical world, that maybe interstellar objects like 3I/ATLAS aren't just detritus. Maybe they're intended, maybe they're placed. Not to observe us, but to see who we are based on how we react. It sounds crazy, you know that. But so did black holes once. So did exoplanets, so did radio from quasars. Every great shift in cosmic understanding started with someone going, wait, that doesn't add up. And nothing about Atlas adds up. There's also the timing, that awkward coincidence, 3 interstellar objects in under a decade, after centuries of none. Yes, we've improved our detection systems. Yes, we're scanning the skies more thoroughly, but the sudden convenience of their appearances still hums with a kind of discomfort. Like we've crossed an invisible threshold, and someone noticed. You wonder, if we're being studied, what would they see? A civilization twitchy with curiosity, 1,000 telescopes all turning at once, 1,000 minds trying to understand a dark rock that doesn't behave properly, that doesn't speak, that only reflects. Maybe that's the test. Maybe the point isn't to announce themselves. Maybe it's to see who we become when faced with a mystery we can't resolve. Do we dismiss it? Do we fight over it? Do we build something new just to follow it? Or do we dream? Because that's the most human response of all, to look up, find the thing that doesn't belong, and begin to imagine the impossible. You don't need to believe that ATLAS is artificial. You just need to ask why the question won't go away. And in the quiet between those thoughts, you hear nothing but the hush of an object sliding through space, unbothered, undetected by most, unclaimed by any. An object that might be alien, or might just be more than we ever expected. The thought that 3I/ATLAS might be more than a rock doesn't leave your mind. It just changes temperature. It cools, lingers, and settles into a strange sort of background radiation beneath your skull. Because even if it's not artificial, even if it's just a piece of something long dead and long ejected, there's still the matter of where it came from. And that question isn't speculative, it's fundamental. That object, drifting now somewhere between the orbits of Mars and Jupiter, has a home, a star, a past, a point of origin so far away and so long ago that the idea of tracing it is like trying to find the birthplace of a single snowflake in the middle of a blizzard. Still, astronomers are trying. They've already run backward simulations, tracking its incoming vector as best they can. Using the data we've got, they wind the tape back, modelling its approach trajectory through the solar system's gravitational soup, and then projecting that motion beyond the sun's influence, back into the raw emptiness of interstellar space. The goal? See where it might have come from. Spoiler, it's not clear. Unlike Borisov, which had a relatively straightforward approach that pointed generally toward the constellation Cassiopeia, ATLAS comes in at an odd angle, highly inclined, hyperbolic, and frustratingly ambiguous. Its incoming velocity relative to the sun clocks in around 26.8 kilometers per second. That's fast, but not too fast. Certainly within the expected range for interstellar debris. But the direction, that's where things get messy, because stars move. The galaxy isn't a still painting, it's a turbulent, spiraling mess of motion. Every star you see in the sky is drifting, wobbling, dancing through the Milky Way at different speeds and vectors. So when you try to trace Atlas's path back in time, you're not just pointing at a constellation and saying, there. You're running a chaotic ballet of stellar orbits, billions of possibilities, and trying to figure out which ones might have intersected with ATLAS's trajectory millions or billions of years ago. Historians still argue over whether we'll ever be able to confidently link interstellar objects to specific stellar systems. Some say the galactic drift is just too complex, that over the timescales these objects travel, the stars themselves have moved too far to pinpoint. Others are more optimistic, pointing to missions like Gaia, which is mapping the positions and motions of over 1 billion stars with stunning precision. With data like that, some researchers hope we'll be able to triangulate the origins of future interstellar visitors. If not this one, then the next. For now though, the best we can say is, a TLAS came from somewhere. Likely a young star system that shed a bunch of icy debris early in its formation. Maybe something like our own solar system, back when Jupiter was still knocking things around like a drunk at a wedding reception. That's the current leading theory, that 3I/ATLAS is a fragment of early planetary formation, cast out by gravitational interactions into the deep freeze of interstellar space. But even that scenario is full of loose ends. If it was ejected billions of years ago, how did it survive so long? The surface, as far as we can tell, doesn't show obvious signs of cosmic erosion. No deep impact scars, no extreme discoloration from ultraviolet exposure. It's dark, yes, but that's more suggestive of processed material than weathering. You'd expect more pitting, more signs of a long, harsh journey. So either it's younger than expected or it's tougher. One fringe hypothesis, the kind buried deep in preprint archives, just above the flat Earth theorists but below the people who think black holes are portals to Atlantis, suggests that 3I/ATLAS might have been ejected recently. Not galactically recently, but maybe a few million years ago. That sounds like a long time, until you realise it's a blink compared to the 13.8 billion year timeline of the universe. If that's true, then maybe it came from a nearby star. Some candidate stars have been named GJ, 436, Epsilon Eridani, or even Alpha Centauri, all within a dozen or so light years, all possibly volatile with young planetary systems and plenty of gravitational turbulence. But again, the models can't lock it down. The backward calculations degrade over time. Too many unknowns, too much cosmic noise. And then there's the wild card. What if 3I/ATLAS didn't come from a star at all? Some researchers have proposed that a significant portion of interstellar debris doesn't originate in star systems, but in interstellar space itself. That is, in the chaotic regions between stars, dense molecular clouds, collapsing nebulae, or even failed starlets called brown dwarfs. Maybe Atlas was formed in the dark, in places where sunlight never reached. Maybe it never had a home in the traditional sense. That idea is both freeing and deeply unsettling. It removes the need for a dramatic ejection. It erases the idea of a star system at all. It implies that material can coalesce, fragment and drift without ever being touched by a sun. And if that's the case, then the number of possible origin points for 3I/ATLAS goes from a few thousand candidate stars to millions of cubic light years of uncharted dark. You remember reading that Voyager 1 is only just now entering interstellar space, and even then, it's still within the sun's gravitational influence. It would take another 30,000 years to reach the true space between stars. That's how big the gaps are. That's how much empty distance 3I/ATLAS had to survive. Tens of millions, maybe hundreds of millions, of years travelling through cold, empty silence. No light, no sound, no gravity to hold it close, just inertia, just motion. And yet it arrived here, at this moment in time, with enough momentum to graze our sun and leave. It chose, unconsciously or otherwise, this solar system, not another, this place, this era, this civilization. That coincidence is cosmic in scale, but it's still a coincidence, or it's not, because that thought won't go away. That maybe, just maybe, these objects don't arrive randomly. That maybe they're the breadcrumbs of someone else's journey, or the artifacts left behind by civilizations that died out before Earth even formed. Some astronomers have speculated that if alien life is common and intelligent life is rare, then the galaxy might be full of dead tech, structures, fragments, even waste, drifting between stars with no remaining context. And we wouldn't recognize it. We'd call it a rock. We'd name it 3I/ATLAS. We'd plot its orbit. We'd try to find its home. But we wouldn't know. And maybe that's the point. Because when you're looking into the void, sometimes what matters isn't where something came from, but the fact that it came at all. Your thoughts begin to slow, stretch thin across cosmic time, like light filtering through an ancient window. You're not thinking in equations now, or models, or orbital elements. You're drifting, just a little, trying to feel what it would be like to be 3I/ATLAS, to be that silent traveller, no longer tethered to any star, no longer part of any system, just coasting through the darkness with no destination and no memory of departure. You imagine the cold, not the kind you can survive, but the kind that doesn't end, the kind that doesn't even hurt because pain is a luxury of heat. Atlas has been in motion for what might be tens of millions, maybe hundreds of millions of years. That's the part people keep glossing over, not just where it came from or what it is, but how long it's been alone. You think about that too much and your brain begins to retreat, like it knows it's not supposed to go that far out, that far back. Because even time feels different out there. It's not clocks and calendars. It's entropy, slow decay, the erosion of everything down to dust and silence. Historians of astronomy have always framed space in terms of wonder, planets with names, stars with stories, constellations drawn from myth. But interstellar objects like Atlas don't fit into those cozy categories. They don't twinkle in the night sky. They don't mark seasons or inspire poetry. They don't stay. They're reminders of the real scale of things. That most of space isn't organised into charming planetary systems. Most of it is void. And in that void, sometimes, rarely, a stone like Atlas drifts through a system that can't help but notice. And we did notice. That's the miracle, the sheer improbability of it. You imagine that object travelling in darkness for eons, passing light years of empty space. How many systems did it miss? How many planets did it pass too far to matter? And yet somehow here it is, within view, within reach. A brief intersect in the great galactic shuffle, a cosmic handshake that lasts a few months before fading back into nothing. You picture it. Out there, right now, beyond the reach of Earth's naked eye, but still watched by a handful of dedicated telescopes. Silent, tumbling perhaps, maybe shedding dust, maybe not. No spin signature we can fully decipher, no signals, no flares, just motion. And beneath that motion, what? Is there intention, or just inertia? You try to imagine ATLAS's perspective, not metaphorically but literally. What does the universe look like from the surface of that object? There's no sound, no sunrise, just endless dark, punctuated occasionally by the warmth of a passing star. You wonder how many times it's passed near other suns, how many brief glimpses of golden light it's seen, how many times it could have been caught, but wasn't. It's a lonely image, but also a noble one. This is what space is, not battles and warp drives, just dust and stone and time, woven together across unimaginable distances. Atlas doesn't need a purpose to be meaningful. Its existence is the message. Still, there's something comforting in assigning it purpose. It's human. We do it with everything. Comets, dreams, badly timed emails. We shape stories around silence because silence is too big to live with. And maybe that's why ATLAS matters. Not because it might be artificial, not because it might be a probe or a relic or a galactic message in a bottle, but because it's a reminder that the universe is alive with motion, that the things between stars don't always stay there, that sometimes something truly ancient drifts across your sky, and you notice. Even now, telescopes around the world are watching it fade. It won't be with us much longer. Its hyperbolic trajectory guarantees that. It's already on its way out, picking up speed as it escapes the sun's gravity forever. There's no second pass, no elliptical return. It came once, uninvited, and it won't come again. You think about that kind of finality. It's not a kind of death, not really. It's more like a cosmic shrug, a passing, something witnessed but never fully understood. And the odds that we even saw it at all? Astronomical. If it had arrived a few years earlier, we might have missed it. If it had passed a few degrees higher in the sky, it could have slipped through the gaps in our scanning systems. If its surface were a bit darker, if the angle were a bit shallower, anything, maybe it would have just drifted through untouched, and we would have stayed unaware. But we didn't. We saw it. And seeing matters, even when we don't understand, especially then. Because the truth is, we'll never know everything about ATLAS. Not in this pass. Not in this century. There won't be a mission to chase it down. No probe to catch up and peek under its skin. It's moving too fast. It's already too far. The door is closing. But what we do have is the knowledge that something came. Something not from here. Something that wandered and passed close enough for us to wonder. And that wonder will ripple out for decades, across papers and theories and generations of scientists who grew up knowing the names Oumuamua, Borisov, and now Atlas. You let yourself go quiet. You stop reaching. You stop asking. And for a moment, you simply exist with the thought of ATLAS drifting through the dark. Not a visitor, not a threat, just a fact, a presence, a sliver of the unknown, passing through your corner of the galaxy like a feather on the wind. And as your thoughts soften, so does the world. The questions don't fade, they stretch. They spread across your mind like starlight across deep water. Wide, calm, quiet. Let them stay there, unanswered. Let them drift with you into the night. You let your breath settle. Eyes closed now, but your mind still tethered to the sky. Somewhere out there, 3/ATLAS continues its silent departure. One more mystery we've learned just enough about to realize how little we understand. And yet, despite the silence, the science presses forward. There's always one more question, one more layer of data to pick apart, one more signal to search for in the static. So now your thoughts drift, ever so gently, to the one place they were always going to end up. Are we listening? Are we really listening? Because if Atlas is anything more than a rock, if there's even the faintest shadow of intentionality behind its journey, then surely someone somewhere is putting their ear to the sky. That someone naturally is SETI. The search for extraterrestrial intelligence has never really left the stage. It just shifts quietly between the spotlight and the wings, always listening, always waiting. Ever since 3/ATLAS was confirmed to be interstellar, a few scattered dishes and arrays around the world tuned in. Not to the object directly, but to the space around it. Hoping, just maybe, to hear something. Not a message, not a song, not even a take me to your leader, just anything, a frequency shift, a pattern, a structured blip in the noise that could hint at something more than rock and ice. But so far, static. That's not unexpected. Most SETI scans end that way, no signal, no surprise. But that hasn't stopped the quiet hum of interest behind the scenes. Even now, the Allen Telescope Array is running periodic sweeps along ATLAS's projected path, checking in just in case. They're not blasting out greetings, not yet. No transmissions, only listening. Because there's an unwritten rule in this game. You don't call until you're sure someone's on the other end of the line. Historians still debate whether the SETI movement is more science or philosophy. Some call it a project of hope, others a monument to loneliness. But one thing's always been true. We search not because we expect an answer, but because not searching would mean accepting that no answer will ever come. And if that's not the most human impulse in the universe, what is? So now, as Atlas coasts through the inner solar system, researchers are watching closely for any anomalies. Not just electromagnetic signatures, but thermal inconsistencies, radar returns, anything that doesn't line up with the behavior of a natural object. A signal doesn't have to be Morse code or binary pulses, it could be heat radiating in the wrong pattern, or a sudden, inexplicable shift in rotation, or a faint EM spike that repeats just a little too perfectly. Some of the more ambitious SETI groups have even started using machine learning to comb through the data. Not looking for messages, just anomalies, patterns that our human minds wouldn't catch. Some of these models are trained on vast datasets, pulled from years of sky surveys. One lab even adapted a neural net originally built to detect fraudulent credit card transactions. Apparently, the behavior of alien artifacts and shady banking patterns share certain statistical quirks. Who knew? And then there's the fringe, the enthusiasts, the believers. They're listening too, though not with telescopes, with homemade antennas, hacked satellite dishes, even repurposed ham radios. They point their gear skyward, hoping to catch something the big machines missed. Some live stream it, their websites filled with scrolling graphs and buzzing spectrograms. Most of it is noise, all of it really. But still, there's something admirable in their persistence. They don't need a grant. They don't need peer review. They just need the sky, and the belief that someone might be trying to say something. And in a way, that makes them part of the experiment too. Because if Atlas is a message, not a probe, not a machine, but a message in physical form, then the message is this. Will they notice me? Will they listen? You think of Voyager, of Pioneer, of those golden records we sent out like bottles into an infinite ocean, each one etched with music, diagrams, greetings, instructions, a handshake without a hand to shake. Those weren't messages of content, they were messages of existence, and maybe Atlas is that too. But the silence, of course, remains. No pulses, no beams, no whispers across the void, just the ticking of data points, the cold echo of a thing that seems to move with purpose, but says nothing. Still, that absence is loud in its own way. It's been said before, if the universe is silent, perhaps we are still in the waiting room, or perhaps the language being spoken is one we don't know how to hear yet. And if 3i/ATLAS is saying something, maybe we're just not listening the right way. Maybe the signal isn't in the radio bands at all. Maybe it's in the trajectory, in the timing, in the way 3 interstellar objects have now arrived in a single decade, in the shape, the spin, the missing pieces. What if we've been assuming the message would sound like a ping, when in fact it looks like a question mark streaking across the sky? Or perhaps the silence is the message, a reflection of our own cosmic youth. You lie still and let that idea bloom in your mind, quiet and full. The notion that the universe might be watching, waiting, evaluating us, not on how we respond to a signal, but on how we handle no signal. What do we do with mystery? What do we do when we aren't given answers, but are left with only shadows? Do we invent stories, send probes, build better telescopes? Do we shout into the dark, or do we listen longer? In a way, 3i/ATLAS is the perfect challenge. It doesn't threaten us, doesn't demand anything. It just is. It passes by, inviting us to observe, to study, to question, to wonder. It gives us nothing, and in doing so gives us the chance to define ourselves by how we respond. And maybe, just maybe, that's the whole point. You're still awake, barely. The world around you is hushed now, and the soft hum of your fan merges with the imagined hush of space, as if you're floating between worlds. It's a comfortable kind of emptiness. And yet, despite all the silence, you can't stop thinking about the noise, the humankind. Because every time a new object like 3i/ATLAS appears in the sky, Earth gets loud. Not in a technical sense, no rocket launches or planetary defense alarms, but in the social sense. In the way your species starts to buzz. It always starts the same way. The press release, dry, factual, something like, new hyperbolic object confirmed. Designated 3i/2024 QZ1 Atlas. But before the ink dries on that PDF, the gears of the internet start turning. Headlines mushroom, tweets multiply. YouTubers post animations with overly dramatic music. There's always one thumbnail with a blurry black rock hurtling toward Earth, and the word warning in bold red. And there's always someone in the comments asking if this means the end of days. It never does. But that's not the point. You've seen this pattern before. With Oumuamua, people speculated almost immediately, some with genuine curiosity, others with gleeful alarmism. Was it a spaceship? Was it a surveillance probe? Was it the harbinger of some forgotten prophecy from an ancient calendar? Never mind that it was tumbling end over end like a drunk baton. Never mind that it was already leaving by the time anyone even noticed it. The mystery was enough. And then came Borisov, a more normal visitor, but even then the headlines returned. Second interstellar object discovered. Is it watching us? You remember reading that article and the mental whiplash between the title and the actual content. Just ice, dust and a dash of carbon monoxide. But by that point the cultural momentum had already taken over. And now with Atlas the same script plays again. Scientists say one thing, people hear another, and somewhere between the data and the drama, a very human kind of fear seeps in. Historians have documented this pattern for centuries. Sky-based panic is practically a genre. Halley's comet in 1910. People genuinely feared the Earth would pass through its tail and be poisoned by comet gas. Vendors made a killing selling bottled comet pills and oxygen in glass jars. In the 1990s, Comet Hale-Bopp inspired everything from backyard star parties to apocalyptic cults. You remember the tragic story of Heaven's Gate. 39 people who believed a spacecraft hidden behind the comet was coming to take them home. They didn't survive that belief, and yet, the fascination never ends. The skies have always had a way of stirring up something primal. Maybe it's because they're so big, so unknowable. Maybe it's because deep down, humans are wired to see meaning in movement. Stars are fixed. But when something moves, something crosses the sky. That's when the stories begin. In the ancient world, those stories were divine. A comet might be a sword, a messenger, a god's warning. In China, detailed records of comets go back thousands of years, with each celestial visitor tied to the fate of emperors. In medieval Europe, they were signs of pestilence and war. In the Americas, some cultures saw them as spirits. The Aztecs recorded them with awe, suspicion, and reverence. And now, in the 21st century, we call them anomalous objects. We file them under spreadsheets and observational data. But the instinct is still the same. You see something moving through the sky that wasn't there before, and your brain wants to give it meaning. That's where things get strange. Because in a vacuum of official certainty, people invent their own truths. Some say 3I/ATLAS is a weapon, fired from some unseen arm of the galaxy, aimed not at Earth but at perception. Others claim it's proof of ancient knowledge, that the Egyptians or the Dogon people or some secret order knew of interstellar visitors all along. TikTok swells with clips of crystal pendulums and astrology charts, proving that a TLAS is linked to the rise of human consciousness. And while most of it is nonsense, part of you gets it. Because mystery demands resolution, and when science says we don't know, the human imagination rushes in with all its baggage. The scientists, for their part, try to hold the line. They give interviews, write articles, appear on podcasts. They remind everyone that ATLAS is not on a collision course, that it's just passing through, that it's almost certainly natural. But those reassurances don't land the way they used to. Not because people distrust science per se, but because people want to believe in the extraordinary. There's a hunger. You can feel it even now, curling behind your ribs. That quiet desire for something bigger. Something to shatter the ordinary. Something to prove once and for all that we're not alone in this vast, dim universe. So when an interstellar object appears, silent, fast, uncaring, it becomes a kind of mirror. You project onto it what you most want, or fear, to see. For some, it's just data. For others, it's destiny. You lie still now, half amused, half unsettled. Because this is what ATLAS has done, this dark, indifferent traveller. It stirred the cauldron again, not with any beam or broadcast, just with its presence. No tail, no glow, no signal, just a quiet cut through space. And yet look at us, listening, arguing, searching, reaching. The object might be moving away now, already past its closest approach, already bound for the far side of the solar system. Soon it will be too faint for most telescopes to track. It'll disappear into the math, just a name, a plot point, a few lines in a chart. But its cultural wake will ripple on. For some, it will be remembered as the third interstellar object. For others, as another cosmic mystery. For a few, as a message, a warning, a promise. Or maybe a sign that we're not waiting for contact. Maybe we're already in it. The thought lingers now, soft and strange. Maybe we're already in it. Not in the contact, but in the part that comes before. What ancient mythologies might have called the omens. You're not being mystical. You're just noticing how things echo, how 3I/ATLAS, despite being small and quiet and harmless in the purely physical sense, has rippled across our culture like a pebble in still water. And if there's one thing you've learned from both history and sleep-deprived stargazing, it's that people have always looked to the sky for meaning, sometimes out of hope, sometimes out of fear, sometimes just because the ground doesn't have any answers. You imagine just for a moment what an ancient civilization might have done if they'd spotted 3I/ATLAS streaking across the sky. Picture it. A dark object moving with no comet's tail, no glowing arc, just a faint flicker, moving too fast, too straight. No myth could explain it. No priest could interpret it. And yet they try. That's what humans do. They build stories around the unknown because silence demands filling. In fact, some researchers in archaeoastronomy, the very serious-sounding study of how ancient people interpreted the skies, suggest that this might not be the first time such a thing has happened. Not the first interstellar visitor, and not the first time it stirred something in the human heart. There are odd petroglyphs here and there, spiral carvings, star-like symbols intersected by arrows or long streaks, in Peru, in Sardinia, in the American Southwest. These patterns don't scream interstellar object, of course. They don't include eccentricity plots or light curves, but they do suggest that people were paying attention to things that move differently than everything else. Historians still argue whether certain ancient texts describe comets or something stranger. The Chinese records are especially detailed. They've catalogued comets for thousands of years, describing not just their appearance but their behaviour. Some of those descriptions match known cometary activity, others don't. One particularly odd entry from the Han Dynasty describes a guest star that moved like a spear, fast, silent, and without a tail. It lasted only a few nights, and then was gone. To be fair, it could have been a meteor, a near-Earth object, or even observational error. But you can't help but wonder, what if it was something like ATLAS? What if interstellar objects have passed through our skies before, unrecognised, unclassified, but remembered? The thought is a little thrilling. That ancient people might have seen what we're seeing now, looked up and felt that same chill, that same tension, the sense that something's not quite right up there, that something has entered the pattern but doesn't belong to it. And if they felt that, what did they do about it? You imagine a ritual, a night vigil, someone watching the stars for change and recording what they see with scratches in rock or ink on parchment. Not because they understood orbital mechanics, but because they understood that meaning sometimes arrives without context. And when it does, you don't ignore it. You mark it, you pass it down. That's where the archaeologists come in. Not the ones digging up temples, but the ones sifting through myths and oral traditions for subtle signs of sky watching. Some legends include strange visitors from the heavens, dark stars, cold gods, silent travellers. They're always outsiders. They arrive, shift the story, and leave. The parallels aren't perfect, but they're there, and you start to see how 3I/ATLAS fits into a very old framework, the sudden arrival. It's a motif older than books. Something comes from outside, it moves through the centre of the world, and then it's gone. Whether it's a comet, a god, or a wandering stone from another system doesn't seem to matter. What matters is the feeling, that ripple of the unfamiliar crossing the sky. Modern culture still does this, of course. We just use different tools. We track with telescopes, not oral tradition. We post graphs instead of prophecies. But the emotional response, it's not so different. The unease, the awe, the need to name the thing and understand it. That's ancient. That's human. And then there's the part no one talks about, how objects like ATLAS age our thinking. They make us remember how young we really are, technologically, historically, cosmically. Think about it. We've only had the ability to detect interstellar visitors for a few years. Our telescope systems have only recently become sensitive enough to spot these fast, faint interlopers. We are, as a species, just now opening our eyes wide enough to see what's always been there. And that changes us. Because the sky used to be a dome, then it became a sea, then a frontier, and now it's a hallway, a place things move through. Atlas isn't the destination, it's the passerby. It doesn't speak, but it shifts the room, and in doing so, it forces us to ask what else might be moving through the same hallway, unseen, unmarked, unnamed. You remember reading about the concept of deep time, the almost painful awareness of just how long the universe has been doing its thing without us. Interstellar objects like ATLAS are deep time incarnate. They carry the silence of ancient collisions, the echo of forgotten systems. They are the artifacts of galaxies in motion, remnants of things that were destroyed before Earth ever cooled. So maybe, just maybe, the ancients were right to treat the sky with reverence. Not because gods lived there, but because it was the only place big enough to hold memory. Real memory. Galactic memory. The kind that travels through systems uninvited, silent, slow, and forever unknown. And now, we see what they saw. With better tools, yes, with clearer data, but with the same essential wonder, the same tension between not knowing and needing to. So you close your eyes, imagining ATLAS above you, not in a telescope image, but with your own eyes. A flicker, a visitor, no tail, no glow, just presence. It's passing through, like so many others must have. But this time, we saw it, we remembered it, and that, in the end, is what connects us to every stargazer who ever looked up and felt small. Not the answers, the questions. And now, just as you're starting to think you've wrapped your brain around 3I/ATLAS, just as the pieces begin to feel like they might settle into something like understanding, something happens, the math falls apart. The orbit, so clean in theory, begins to glitch in simulation. The models, once elegant, suddenly can't decide whether ATLAS is tumbling naturally or doing something stranger. It's not that the data is wrong, it's that it refuses to behave. It refuses to stay in the box. You wouldn't think orbital mechanics could feel rebellious. This is the math of planets and stars, after all. Predictable, timeless, tested to absurd precision. But in Atlas's case, the equations start groaning under the weight of the unknowns. It's like trying to balance a chair with one leg missing and discovering that gravity might also be drunk. The issue lies in the small things. Tiny residuals, micro-deviations. You run the model once, it shows a clean hyperbola. Run it again, using the same initial conditions, and suddenly you're half a degree off. Not a lot, just enough to matter. Just enough to make a room full of orbital analysts frown and start adjusting parameters at 3 a.m. while clutching lukewarm coffee. This happens more than you'd think, especially with interstellar objects. Oumuamua had this problem too, the infamous non-gravitational acceleration that no one could pin down with confidence. With Atlas it's worse, because there's less to see. No outgassing, no visual tail to account for, no physical structure to help explain spin. All you've got is motion. And motion, annoyingly, is the one thing that should obey the rules. But Atlas is throwing spaghetti into the machine. The orbital models are starting to show signs of chaotic sensitivity. That's the fancy way of saying tiny measurement errors result in wildly divergent outcomes when projected forward or backward in time. You tweak the brightness interpretation slightly. Atlas now exits the solar system a degree north. You change its assumed mass. Suddenly it doesn't come from where you thought. Historians still argue whether earlier anomalies like this were due to instrument error, software artifacts, or just plain cosmic weirdness. And now you're watching astrophysicists try to untangle it all like exorcists debugging haunted spreadsheets. Even NASA's orbital simulations have quietly added disclaimers to their ATLAS projections. Words like provisional and non-deterministic appear in footnotes. In the world of orbital mechanics, that's basically waving a white flag and saying, we don't know. Yet. There's a kind of poetry in that, you think? The most precise minds in the world, armed with the best telescopes, the most powerful computers, the most advanced orbital modelling software, brought low by a single rock that won't sit still in the equations. You hear whispers now from people running open source orbital models. Forums light up with phrases like chaotic attractors and insufficient convergence. The kind of mathematical warnings that, when translated into human terms, mean this object is messing with us. Some theorists even start reaching into the fringes. They propose that ATLAS might be interacting with the solar wind in an unusual way, or that it has a highly irregular shape, maybe even concave surfaces, that catch radiation unevenly, causing unpredictable forces. But without direct imaging, it's guesswork. Very smart guesswork, but guesswork nonetheless. Others, more cautiously, suggest that perhaps we're hitting the limits of our current gravitational modelling. That perhaps there are microforces at play, tidal interactions from passing near massive bodies, or weak magnetic influences we haven't yet accounted for. It sounds boring, but it's not. It's the scientific version of someone whispering, "What if the rules don't quite apply here?" One particularly cursed evening, a graduate student's error plot was misinterpreted by a journalist as evidence of an intelligent trajectory correction. Within 12 hours, conspiracy forums were full of diagrams, arrows, and impassioned declarations that Atlas had adjusted its orbit mid-flight. Never mind that no such thing had happened. The story had taken on a life of its own. But deep down, you kind of get it, because there is something unsettling about how the models keep slipping. Not dramatically, not enough to rewrite textbooks, but just enough to raise eyebrows, and just enough to remind you that sometimes the universe doesn't fit your spreadsheets. Sometimes it does something that makes the software crash, and the scientists sigh, and the poets lean forward with a little smile. It reminds you of chaos theory, not in the overused movie sense with butterflies and dinosaurs, but in the pure mathematical sense, that the universe is deterministic, yes, but in a way that becomes functionally unpredictable beyond a certain point, especially when the input is limited, especially when the object doesn't give up its secrets easily. And ATLAS? Atlas gives you nothing. No reliable light curve, no regular spin, no predictable pattern of brightness. You put it into the model, and the model comes back sweating. Someone joked online that Atlas is like the cosmic equivalent of a 404 object not found error. It exists, it's real. But try to define it, and the system panics. There's a long history of these kinds of problems in science. The orbit of Mercury didn't make sense until Einstein rewrote the rules. The behavior of electrons was madness until quantum mechanics arrived with its tiny chaotic toolkit. You wonder, just a little, if interstellar objects like ATLAS might be the next chapter of this tradition. Not because they're magic, but because they don't quite fit. And maybe that's not a failure of the object, and maybe that's a failure of us. Because what if our entire mental framework, our models, our assumptions, our tidy folders labelled comet and asteroid, just aren't designed to handle something that doesn't play by local rules? What if Atlas is the first of many reminders that the universe is far more improvisational than we thought? You let that thought settle. You let the equations melt into metaphor, because math has its limits, and sometimes, when the orbit falls apart, all that's left is wonder. It's somewhere out there now, 3I/ATLAS, shrinking into the darkness, just a fading speck in the deep. And yet, as the buzz starts to quiet, as the headlines lose interest and the simulations stop crashing, a strange new thought emerges. What if this isn't rare at all? What if interstellar objects like this are passing through all the time, and we just haven't noticed? Until recently we were blind to them. It's easy to forget how new this all is. Until 2017, not a single interstellar object had ever been observed from Earth. Then Oumuamua blazed through, followed by Borisov, and now Atlas. 3 in less than a decade, after millennia of silence. You start to feel the statistics bend in your hands like warm wax. That's not luck, that's revelation. Some astronomers have started to whisper it aloud. Maybe these visitors are common. Maybe they're everywhere. And the truth is, we might have been missing them all along. Before we had all sky survey systems like Pan-STARRS and Atlas, the telescope network, not the object, our chances of catching a fast, dim interstellar speck were astronomically small. These objects are tiny, dark, fast. Their window of visibility, just a few weeks or months, is narrow and easy to miss. If they pass on the far side of the Sun, or enter from a low inclination angle, they could sail right past Earth unnoticed. Historians still argue whether some of the comets recorded in medieval star charts or ancient Chinese texts might have been interstellar. We didn't have the tools to measure eccentricity back then, just hand-drawn maps and poetic descriptions. A guest star that moved swiftly, one record says, with no tail and vanished in silence. That could be a comet, or something stranger. We'll never know. But now that we're watching more carefully, the numbers are changing. A 2023 paper modelled the detection rates of interstellar objects and came to a startling conclusion. We may have dozens entering the solar system every year, maybe even hundreds. Most are too small to spot. Pebbles, grains, dust. But they're out there. And once in a while something like Atlas passes close enough, bright enough to be caught in the act. You think back to 2014. No one talks much about that year in this context, but something interesting happened. a small meteor exploded in the atmosphere over Papua New Guinea. It wasn't big, maybe a meter wide, just enough to light up the sky for a few seconds and scatter fragments in the ocean. At the time, it was just another fireball. No one paid much attention. Years later, scientists reviewed the trajectory data. High entry speed, a steep angle. When they crunched the numbers again, they realized this rock didn't come from the solar system. It was interstellar, a space bullet burned up in our skies, never catalogued until long after it had gone. The US Department of Defense had classified some of the tracking data, just enough to make it controversial, but eventually it was confirmed. Interstellar object number, well, technically 0, discovered before Oumuamua, but not recognised until after. So really, ATLAS isn't the third, it's the fourth. And if you count suspected cases, maybe the 5th or the 10th. That realisation shifts the ground under your feet. You start to wonder, how many have passed while we were looking the other way? How many are drifting through right now? Too small, too dark, too fast for even our best machines to catch. That's what makes the scientists giddy. Not just the strangeness of ATLAS, but the implication of it. The idea that we've only just begun to see the true traffic of the cosmos. That we're sitting on the side of a galactic highway and only now realising how many vehicles have already passed us by. Some researchers believe that future sky surveys, like the upcoming Vera C. Rubin Observatory and its Legacy Survey of Space and Time, LSST, will spot dozens more of these objects every year, maybe even hundreds. And with that many interstellar samples to study, we might finally begin to understand what's normal and what isn't. Maybe Atlas will prove to be an outlier, maybe it won't. But if these objects are common, that raises another question. One that scientists are only just starting to tiptoe around. Have any of them ever landed here? Because it's one thing to spot an object passing through, it's another to realise that over billions of years, interstellar material has probably been falling into Earth's atmosphere. Not just once, not twice, but many times. Most of it, of course, would burn up, disappear into streaks of fire, but some fragments might survive. Meteorites that land in oceans, tiny pebbles buried in polar ice, pieces of alien rock, older than Earth, sitting in museum drawers misclassified as just another asteroid shard. That idea has sent a quiet ripple through the meteoritics community. Teams are already scanning old collections for odd chemical signatures, looking for isotopic ratios that don't match anything from the asteroid belt, traces of oxygen or carbon that whisper of distant stars. One lab even believes they've found an anomaly, a sample with unexplainable isotope ratios and an unusual crystalline structure. They won't say more yet, but the hint is there. And if even one such fragment is confirmed, then the dream changes. It means we don't have to wait for visitors. We've been visited already, not by ships or messages, but by matter, by pieces of other worlds, other beginnings. It would mean that the galaxy isn't just something we observe, it's something we touch. And if that's true, then ATLAS isn't an exception, it's a pattern. And the real story is only beginning to unfold. You blink up at the ceiling, or maybe it's the sky now. Your thoughts so far removed from Earth that the difference hardly matters, and there's only one truth left to face. 3/ATLAS is leaving. It always was. That was the deal from the start. It came in fast, crossed our solar system in a clean hyperbolic arc, and now it's heading out again. Forever. No return, no orbit, no second chance. This wasn't a visitor that stayed for tea, this was a drive-by from the deep unknown. You check the numbers again, even though you know them by heart. Atlas is already outbound, accelerating under the sun's waning pull, cutting through the orbits of Mars and Jupiter like a thief slipping through alleyways. The solar system barely tugged at it. No capture, no deflection. It didn't so much as flinch as it passed the major planets. Just a clean exit, gone in a matter of months. The speed? Roughly 26.8 kilometers per second relative to the Sun. That's blistering when you compare it to Earth's own orbital velocity, which is about 30 kilometers per second. But Earth is in a loop. Atlas isn't. Its trajectory isn't a circle or even a stretched oval. It's a perfect escape line. The kind you see in textbooks to explain how objects leave. The kind that doesn't bend back. And you sit there, grappling with that finality, because you know with near absolute certainty that no human will ever see this object again. No spacecraft will chase it. No mission will intercept it. It's already too fast, and even if we launched something today, it would be a miracle of engineering just to catch up, let alone slow down enough to take a look. Historians still argue whether we missed our chance with Oumuamua, if maybe we could have reacted faster, built something smaller, lighter, quicker. With Atlas, there were murmurs of a rapid response mission, a few whiteboard sessions and a few ambitious labs, but nothing concrete. No budget, no time. The window was too small, so now, like Oumuamua and Borisov before it, Atlas will become a ghost. Not a haunting one, but a phantom of data. Just graphs and numbers and simulations from now on. It'll fade into background memory, its last position logged, its trajectory charted, but its secret still intact. Its mystery, if anything, preserved by distance. You imagine it now, far past the asteroid belt, slipping beyond the region where sunlight still feels like a thing. The space beyond Saturn, past Neptune, out toward the Kuiper belt, and beyond that, the Oort cloud, that hazy shell of icy fragments and ancient leftovers that forms the edge of the sun's dominion. Atlas won't stop there. It's not from here. It won't stay. Give it a few more months and it'll be out of observational range altogether. Too dim for any telescope to track. Just another dot swallowed by infinity. Just another uncatchable thing. And somehow, that stings. Because even though it wasn't ours, even though it never wanted to be known, you did know it. Briefly. You saw it. Or at least your species did, and that counts for something. It's strange, isn't it? How quickly you can become attached to a rock. A faint object moving fast and saying nothing. But that's what happens when the universe tosses something unexpected into your lap. You start to imagine it means something, that it's part of a pattern, a story, maybe even your story, and maybe it is. Because the fact that we saw Atlas at all is kind of a miracle. Think about the alignment required. Not just physically, but technologically. A rock tossed from another star system just happens to pass close enough, in just the right window of time, when we happen to have the capability to notice. That's not divine intervention. It's probability stretched to its breaking point. It's the universe nudging you and whispering, "Pay attention." And so you did, and now it's leaving. Some researchers are tracking its outbound path, projecting its future position tens of thousands of years ahead. They estimate it'll leave the solar system entirely in a few decades, slipping past the last frozen fragments of the Oort cloud. After that, it's truly free, alone again, just as it has been for millennia, maybe longer. Where will it go? Nowhere in particular. It's not headed anywhere, it's just going. Maybe in another million years it'll pass through another system. Maybe it'll be caught by some far-off star, slowed just enough to spiral inward again. Maybe in that system someone will see it, point their own telescopes, run their own simulations, ask their own questions, and maybe they'll wonder where it came from. And they won't know, just like we don't know now. It's poetic in a way, that an object like Atlas moves on such a scale of time that we can't even follow it with thought. Our civilizations rise and fall in the time it takes this rock to blink past a planet. Our languages decay, our maps become meaningless, and still it just goes. There's a strange kind of humility in that. It makes you realise that most of the universe doesn't care whether or not we're looking. It doesn't care what we name things, or what stories we tell, or what hopes we project onto shadows in the sky. The objects keep moving, whether we notice them or not, and yet we do notice, and in that noticing we create meaning. That's the real legacy of Atlas. Not its shape or spin or strange lack of a tail, but the questions it left in its wake. The way it rattled our categories. The way it reminded us that the sky isn't finished surprising us. We'll keep watching, of course. The next one will come. Maybe in a year, maybe in 10, maybe tonight. And when it does, we'll be better prepared. Sharper instruments, faster reactions, maybe even missions ready to go. Maybe the next one won't slip away quite so easily. But Atlas will be gone. A line scratched across the void, now trailing off into silence. We'll remember it though, not because it answered anything, but because it reminded us we're still allowed to ask. And so you lie there, in the hush of almost morning, cradled by the last traces of darkness before the sky decides to turn grey, and you let it sink in. 3I/ATLAS is gone. Not metaphorically, not theoretically. It's physically, irreversibly on its way out of the solar system, slipping into interstellar space with the kind of indifference only a billion-year-old traveller could master. It doesn't leave in anger, or curiosity, or triumph. It just leaves, And you, in all your microscopic human finitude, are left here with nothing but questions, and the knowledge that this happened. There was a moment in time where the Earth and this rock from another star system shared space. You were alive for that. You saw that. Whether through a telescope lens, a news feed, or just a few scattered pixels on a diagram, doesn't matter. It crossed your life, it entered your world, and for a brief flickering window, you knew it was there. You keep thinking about that number, 60%. A 60% chance that something about Atlas doesn't add up. It still floats in your brain like a loose screw in zero gravity. You know it doesn't mean alien, it doesn't mean engineered, but it also doesn't mean solved. It's just enough to keep the door open, to let a little mystery drift in. And maybe that's the most important part, that mystery. Because in the end, ATLAS didn't come here to answer questions. Or if it did, it wasn't talking. It didn't flash lights at us, didn't change course, didn't leave behind a trail of radioactive breadcrumbs or coded debris. It simply moved, through our sky, through our minds. That motion, uninvited, unexplained, is what changed us. You start to realise that 3I/ATLAS wasn't an event. It was a mirror, a test. Not of technology or instruments or orbital math, but of wonder, of imagination, of how we, as a species, respond to the unknown. We tracked it, modelled it, argued about it, projected hopes and fears onto it. Some saw a rock, others saw a message, some just shrugged, others stayed up all night refreshing orbital data, as if meaning might appear in a decimal place. And you? You did what humans have always done. You imagined. You lay awake and let your thoughts stretch across billions of years and trillions of kilometers. You let your mind wrap itself around a speck of darkness moving through a sea of stars. You pictured it tumbling, flickering, drifting. You pictured what it might have been, what it might still be. You let it live not just as data, but as possibility. Historians still argue what Oumuamua was. They'll argue about ATLAS too. Maybe in 20 years someone will look back and laugh at how mystified we were. Maybe new telescopes or probes or instruments we haven't even invented yet will make this all look quaint. Maybe a student will write a paper titled Early Misinterpretations of Interstellar Passages in the Presentient Era, and roll their eyes at us the way we roll our eyes at people who once thought comets were omens of plague. Or maybe they won't. Maybe despite our tech and our graphs and our endless data, Atlas will remain just what it is, a visitor that came without explanation and left with none. And somehow that's perfect. Because mystery has always been the fuel of discovery. Not answers, not facts, but the feeling you're feeling right now. The sense that something is out there, just barely beyond your reach. Something vast and silent and maybe watching, maybe waiting. That's what 3I/ATLAS gave you. Not knowledge, not certainty, but a question. And questions, unlike objects, do come back. They echo, they deepen, they grow over time, they get passed down, translated into new languages, written in footnotes, etched into mission proposals, whispered between stargazers. One day a spacecraft might chase the next one, a real mission. Not just theory and hope, but metal and sensors. Maybe it will catch up. Maybe it'll land. Maybe it'll drill into the surface of a 4I object and find that it's just more of the same. Dust, ice, carbon, nothing dramatic. Or maybe it'll find something that rewrites everything. Either way, the spark began here, with the first few, with Oumuamua, with Borisov, and now with a TLAS. And even if no mission ever launches, even if nothing follows, this will remain a record that we saw it, that we wondered. And wonder is an act of courage. It means looking into the dark and choosing to stay, choosing to ask even when there's no guarantee of an answer, even when the object keeps moving, even when it leaves, especially then, because you don't need a signal to feel connected, you just need to notice. And so you do. You notice. You breathe. You rest your head and close your eyes. Atlas fades from view now. One last point of reflected light swallowed by the edge of perception. Not destroyed, not changed, just gone. But you're still here, and you're listening. So now in the stillness, you let yourself loosen your grip on the questions. You've held them tightly. Too tightly, maybe. All that wondering, all that spiraling possibility. But now it's okay to let them float. Let the unknown be the unknown, at least for a little while. You don't need to solve 3I/ATLAS tonight. You don't need to know what it is, or where it came from, or why it passed through our sky, now, of all times. You don't need closure, you just need stillness, because this is the part of the night where answers become unnecessary. This is the soft part, the part where you're allowed to dissolve a little, to let your edges blur, to imagine Atlas slipping into the dark not as a riddle but as a lullaby, a story without an ending, a question that hums just beneath the skin of the cosmos. You're allowed to let go now. All that urgency, all that curiosity, it's still there, but it's quieter now, like a distant radio signal, barely above the noise. You've asked enough for one night, and the universe will still be here in the morning. The next object will come, the next observation, the next impossible discovery. But not yet. Tonight, there is only you, and the hush between the stars and the knowledge that something passed close, something cold and wordless and older than your entire world. And it did not destroy you, it asked nothing of you, it simply moved on. So breathe deep. Feel the weight of your body easing into the mattress. Feel the air cool on your skin. There's no threat here. Only time, only distance, only space doing what space has always done. You're safe, you're small, you're still listening. Sleep well.